Hello, everyone, and welcome back to the 2023 Hack Summit. I'm joined here by Hilmar Orth, who's the founder and CEO of Gelato. And Gelato is building a next-generation serverless platform for Web3 functions. And it's an amazing technology, and we're excited to hear all about it. And we'll also have time for audience questions at the end. So Hilmar, I believe you have a presentation to give today, but before we give that presentation, I'd love for you to spend a little bit of time with the audience just talking about kind of your background and what got you into Web3 initially. How did you first get into blockchain, and what compelled you to build Gelato?
Yeah, sure. Thanks, Ed, for having me and us as Gelato, of course. So how did I get into the space? So I think I was always very sort of fascinated by the financial worlds, and when I was younger, I started trading quite early. And then I think which got me really hooked and from the crypto perspective was the DAO that happened in 2016. I participated and then sort of got blue pilled and entered the space, and then just started building and was fascinated by the possibilities of building DeFi applications, which we did very early on, like 2018, 2019. But we soon realized that while building like first interest rate swaps and stuff like that there's a bunch of infrastructure missing in Web3 that make all of this very cumbersome. That smart contracts are not really that smart. They're quite dumb. They're quite limited in what they do. They sort of only store logic and state. They don't react to sort of changing conditions on chain or off chain, and that made the use case you could build very limited. And so that's why we started building Gelato in order to help projects augment their smart contracts with off-chain resources, basically.
Awesome. Thank you for that. Well, go ahead and take it away. We'd love to learn from you, so feel free to start the presentation.
Awesome, of course. Cool, then let me share my screen real quick. And by the way, hi, everyone. Thanks for joining in. Okay. Amazing. All right. So today I would like to talk to you guys about, of course, what Gelato is, but I think what we have been focused on in the past half a year to a year, and which is sort of like, I think, the pinnacle of where we are now in terms of the services and the features that we actually identified as being important for Web3 developers to build truly serverless and decentralized Web3 applications, and sort of what this means and how it works. I will get into in a bit, but basically this presentation is about our new service, Web3 functions, that you might have heard of or might not, but this is not an issue. I will walk through it. There's a quick agenda here. First of all, I will talk a bit about the backend architecture of a lot of Web3 applications today and how they operate. Then I will talk about how to build decentralized and serverless Web3 applications using Gelato Web3 functions. Talk a bit about the feature sets, the pros, and then I will also go into a bit of code and show you a demo of actually how you can do it. And if you want to spin up something later today, you can still do it. After this presentation, if you have any questions, feel free, of course, to shoot at me. All right, let's go into how currently or how today most Web3 applications look like from the backend architecture. And I think a common misconception that a lot of Web3 developers have is that just using a blockchain like Ethereum, for example, will enable them to build already sort of serverless Web3 applications, right? Of course, if you go very, very basic, then yes, the only thing you actually need is like a front end, like a hosted React application, plus your smart contract where you store the business logic and the data of your application. But it turns out actually for 99.9% of all the applications out there today that, of course, try to be as user-friendly and feature-rich as possible, there's a bunch of other services required to actually make the whole system work. And after talking to like hundreds of developers in the space, these are sort of like the very common backend Web3 specific services that a lot of them had to build from scratch or leverage in any sort of way. Unfortunately, like one of the first ones that many people have to build, which is not the front end or the smart contract, is actually a system to be able to read data from blockchains in an efficient, scalable manner. If you read data directly from the blockchain, you can get like real-time data of that current block right now. But if you want to go into historical data, if you want to query event data that is not persistent in state right now, this becomes very difficult. And that's why most front ends and most Web3 applications are having to run and build blockchain indexing systems, which is basically, hey, I will track the blockchain, I will listen to events, I will store certain states and certain events in a database. This might be like a centralized database or a decentralized database like IPFS, for example, and then make this data available and easily queryable to my front end. And let's, for example, take an example here of a derivatives trading platform, right, as a Web3 application. A derivatives trading platform has to constantly update its price in order to accurately reflect, let's say, what a certain price of an asset is on a centralized exchange, right? In order to do that, you need to actually send transactions on-chain periodically in order to make your on-chain smart contract system aware of what prices are, right? For these type of things, you actually need to run certain job schedulers. So you need to run these sort of cron jobs off-chain that every, let's say, 10 seconds, 1 minute, execute a certain action, which might be an on-chain transaction, to then update a certain price oracle. And as you might know, using on-chain prices in order to determine, let's say, a derivative price, right, is not really safe because they're manipulatable. That's why you usually use off-chain price data, for example. And for that, you need to, of course, be able to fetch off-chain data, sometimes even like validate that data around like several nodes to make sure the data is not tampered with, to then actually send to your smart contracts and update their state and make them sort of knowledgeable of what happens outside their system. And to send that transaction, of course, you need to have a transaction relaying system. What is transaction relaying? It basically is like an API that helps you write to the blockchain and actually updates the state of your smart contracts to reflect, let's say, that off-chain data that you schedule every minute to be updated, right? Of course, to do all of that in some transaction, you need to have a private key somewhere stored at a server that holds potentially a lot of money. So you need to deal with all sort of security vaults and private key vaults. And let's say a transaction was sent and the price was updated. And let's say that price will lead to a margin position to be liquidated. Then, of course, you should, before that happens, send a notification to your user or notification to your development team that something might go wrong or that they have to take a certain action, right? So you need to be able to actually sort of send notifications on behalf of users. So there's a lot of things going on, and there are sometimes even more sort of backend services that you need to take advantage of. And of course, doing and building and sort of maintaining all of that comes at a cost and introduces quite some problems, right? And like a sort of like very basic first one is that you as a development team now not only have to write the smart contracts, the front end, acquire the customers, but you need to manage, scale, and maintain a lot of server resources. That is, of course, costly, time-consuming, and shouldn't really be the focus of you when trying to acquire customers and expanding your user base, right? A more technical sort of problem here is that it is actually not trivial to have this constant and reliable connection to read and write from blockchains. You need to use certain RPC providers to do that. And unfortunately, especially on L2s or other side chains where block times are very fast, these can be very unreliable, especially at high congestion times. That's why you need to get deals done with multiple nodes operators, maybe even run your own full nodes to get reliable access to these blockchains. And this becomes another burden that you have to do in another cost factor. You could, of course, choose to sort of like pay multiple providers in order to do, let's say, the RPCs and maybe even the event indexing or something, but then you will have to make deals with multiple providers, maybe pay actually in multiple tokens to different sort of addresses, and it all becomes quite cumbersome to also like put it together. And then if you have an application that lives not only on one single chain, let's say Ethereum, but it also lives on Polygon, Optimism, Arbitrum, then your server requirements will basically be replicated for each individual chain that you add, and your sort of overhead will increase linearly there. Of course, there's this whole issue about sensitive private key management in the cloud, which if someone gets compromised from your team, it can have quite the effect on the security of your system. And most importantly, actually, you can still sort of try to do all of this and invest the time and resources, but then at the end of the day, you're building a decentralized application, and you as a development team will become the central point of failure within your system, because let's say the derivatives platform, you stop posting prices or you stop doing certain actions on behalf of users that will prevent them from actually interacting with it, or even worse, will create market opportunities that some other malicious actors can exploit to then arbitrage and, I don't know, take a bunch of assets out of the system from your LPs, for example, right? And so how can we solve this, right? And this is what we always ask ourselves at Gelato at the beginning when we are building these applications ourselves, like, why can't there be a ready-made, decentralized, and serverless sort of infrastructure that allows me to build these applications in a better way? And this is exactly what we're building at Gelato here. We are building Web3's decentralized backend with the aim to empower builders to augment their smart contracts, to create reliable, user-friendly, and scalable Web3 apps, all without sacrificing decentralization and censorship resistance. So this is our goal. And this is why we developed this new sort of primitive that we call Web3 functions. And Web3 functions you can really think of as decentralized cloud functions that enable developers to do a bunch of things. So first and foremost, what it enables you to do is it enables you to connect your smart contracts that live on-chain with computation and data that lives off-chain. Because of a Web3 function, and I will go and show you in a moment, is nothing else than sort of like you can think of it as a digital twin that sort of continuously runs off-chain in parallel to your smart contract and the blockchain that sort of keeps on expanding. And it actually provides you with access to like APIs or other servers that you would like to utilize. Then it also provides you with a way to actually ensure that data that you might want to send from off-chain to on-chain has integrity, is being signed off of multiple nodes, and you can actually combine this sort of integrity here from Gelato with also other off-chain sort of data integrity systems that also sign off of the data. So it's a very flexible way to combine various security mechanisms with each other to provide the highest grade of security. And then, of course, you then need to validate on chain. Then you can still run computation on the data. So you can say, hey, do I actually want to now send a transaction on chain with the data? Or do I want to wait until the gas price is lower or something else has happened? Or do you want to send some other information on chain as well that is not included in that signed data, right? All these things is very flexible for you to decide, are very flexible to decide. Then you can directly interact with all sorts of blockchains, reading and writing. You can send notifications. You can even index and store data. And so it's a very versatile tool that you can use, which can replace a lot of your backend server-side components. And how does it work? So basically what you do is you write this TypeScript file, which is this Web3 function, which I will show you in a second. You can write it, you can test it out, and it calls some APIs that run some computation. Then it can send transactions as a result or can store data as a result for you, right? And what you can do is you can deploy that function to IPFS, and then you get an IPFS ID out, which is basically a pointer to where this sort of logic lives, right? And like in the traditional world, you would upload it to AWS's servers, and then AWS will have it, and then they will run it for you. But here you really publish it to this open decentralized database, which is IPFS. And then what you do is you go to Gelato and you can send an on-chain transaction to the Gelato protocol, which you can easily do via one of our user-friendly UIs. And you include this IPFS ID, which points to this Web3 function. And you can send a transaction to create a task on Gelato, which basically means there's an event on chain that gets emitted. which then tells all the nodes in the Gelato network, where you have multiple node operators in multiple jurisdictions all around the world, that will run this logic for you and then will run the computations and execute transactions at the right time when your Web3 functions say they should be executed. And these Web3 functions can do anything you want them to do. And if a transaction is due to be executed, it will be sent to the Gelato on-chain smart contract protocol, where we enforce some security guarantees, like, is this executor a whitelisted executor? Is this node a whitelisted node? Does this node have the required stake? Are the signatures that you want to check actually fulfilled and signed? Is the data signed off? And then this transaction will go through, hit your target contract to, let's say, updated price in your derivatives protocol on Ethereum. And the features here that you can access in Web3 functions are like, these are like the 8 top ones here. We have TypeScript support, so you don't have to write like some complex Rust or Solidity here. It's just like TypeScript in the Dino runtime, and Dino we use for access security. You have full RPC provider abstraction. So for any chains that we support, you can have RPCs that have high reliability, fallback between multiple providers, and you don't even have to worry about making deals with multiple parties here. You can just use us and leverage a lot under the hood here. You can configure environment variables that other people cannot see, and you can access at runtime. You can make your Web3 functions not only public, but also private. If, let's say, you build really sophisticated trading strategies that you don't want to leak, then you can make them private, for example. You can leverage in-function state management to, for example, say, hey, this is the current state of all the NFTs that I want to buy. And then you do, like, let's say 10 blocks later, you want to cross-check this new state on chain versus the old, and then you can sort of make some decisions based on that. You can pay with a very easy to understand on-chain subscription plan, which is multi-chain. So we developed this subscription plan where you get charged per month, fully on-chain with like no cost to you, and you don't have to send like extra transactions there, and it works across any chain you want. So you can actually deposit USDC on Polygon, and if you send a transaction on Ethereum, you get still charged on Polygon. And then it scales horizontally, so it provides a very, very highly scalable environment. And then what's really cool is you can actually spawn these Web3 functions that continuously run via on-chain transactions. So smart contracts can be the owner of server resources. I know it's a bit weird, but you can literally think of it as like smart contracts spawning servers somewhere in the world that keep running, and then these smart contracts can then sort of shut these servers down again if they want to. And yeah, use cases are across the board, from dynamic NFTs that change based on certain off-chain conditions. When the weather is beautiful, it's like your NFT is sunny, and then when it's bad, like it's raining. It's similar to these Harry Potter images that you see, these Harry Potter paintings that changed. You can imagine like your NFTs on the walls also changing based on some external conditions. Then what I see a lot is that projects use APIs like from 1inch or Paraswap to actually leverage their sort of routing mechanisms to then swap one token to another without having to integrate multiple protocols on-chain themselves in smart contracts, which is great. You can do the same thing with aggregating bridges using protocols like Li-Fi. Then what is really cool is that a lot of projects do is if you need to resolve real-world events on-chain to do like prediction market resolvings, or you need to want to pay out a bet based on an outcome, you can easily do that by calling some betting API and then putting it on-chain. You can go crazy and connect smart contracts with AI. I think now will actually become very prominent using like OpenAI, for example. You can have OpenAI just post on social media platforms like Lens on your behalf all the time. Or you can build your own multi-chain NFT limit order systems with that. So the sky is really the limit. And what I will do now is I will walk you through just a bit of code to give you like a context here on how this all works. Just get a sip. So this is an example website which is super simple. And basically what it does is there's a smart contract under the in the background here. which is called the Hack Summit example. And what it does, it's very simple. It just stores a string, right? So there's this function called setString, and it just stores a random string on chain that we want to like automatically update every 3 minutes. And this string is this one that is displayed right here, right? And we want to basically call an API that just provides us with a random string that then gets published for us every 3 minutes on chain on Polygon, and then that you can see here. And then of course you can sort of extrapolate what you can do with it beyond just posting strings on chain, right? So how it works is we have this template, and you can go to our application called beta.app.gelato.network, and you can click use template. You will be redirected to our GitHub page where you can just use this template or clone this template. But this is basically the template. And what you just have to do is you have to write this Web3 function file. And this is nothing else than inherent, like importing a couple of packages. By the way, you can import whatever npm package you want here, which is great. And then you have to just write this Web3 function .onRun. And what the most important thing is that I will just make it a bit larger here, is that you return two things at the end of the day. You return true if you want Gelato to execute a transaction on your behalf, and you return some call data with a certain function that you want Gelato to execute on your behalf. In this case, we want to execute the setString function. And what we do here is we actually check, hey, do we have at least 3 minutes passed since the last update on chain was done? And if so, then we want to call this Zen quotes API, which is just like a random API, a random string that is returned by this API. And we want to push this string on chain, and we want to store that timestamp at which we sort of did the transaction to know that we don't do it again in 3 minutes. Then what we have to do is we can test this locally. We just run npm test, and then the path of the Web3 function. We see it works very well. And then what we do is we do npx web3f deploy and then the path of it. And what you see right now is that we get this ID out. And this is now the Web3 function now lives on IPFS. We just deployed it for free. We can deploy it as many times we want. We can click this link here and we will be redirected to the Gelato application. And now we already got this IPFS CID pre-filled here, which is great. What we now just have to do is we just have to select the network where the smart contract lists, which is Polygon. We have to get the address of the smart contract. That is actually the address that we want to execute transactions on, which we will do right here. Then we have to select the function, which is the setString function. Then we call it Hack Summit test task. We hit create task. We have to assign it to assign, select the name here, and then we will execute the transaction. And what happens now is we execute a transaction, which then emits an event on chain, and bam, we have the task created. And what is basically happening right now is, by the way, I just created the task already beforehand. So it was sort of paused at the beginning. Now it restarted, as you can see. And we see all the details here. And we also see that I did some couple of transactions before, and we can now check like the task logs. We can see what Gelato nodes actually see. They are still at the state that it was canceled, but soon they will sort of restart it. We can check out the code that our Web3 function has and like the past transactions. And if we wait a bit, then we will actually see that this will update this particular string that we have right now, which I don't now want to sort of wait for, because it will maybe take like a minute or two to actually happen. But yeah, so this is the whole flow of it working, and now it will just update basically as long as I have enough money in my Gelato gas tank here. And maybe if we already seen something here, yeah, look, we can see that a transaction was submitted. This is the transaction hash, and we can just go to Polygon scan, and we can check that now Gelato nodes executed a transaction, it was included. And probably if we go to the web app, we see that, yeah, now it's the Chinese proverb, be not afraid of growing slowly, be afraid of only standing still. Perfect, worked great. And yeah, to round things up, yeah, so Gelato is already used by over 200 projects in the space, from derivatives to aggregators to DEXs to NFT projects to games to yield farming protocols and so on. So if you're a developer watching this, definitely feel free to reach out to us. We're super happy to get you on board and started and help you decentralize your Web3 backend. And yeah, so our private beta for Web3 functions is live right now. Definitely check it out. Reach out to us in our Discord, on Twitter, if you want to get started. And yeah, thanks a lot for Hack Summit, of course, for inviting us in here. And yeah, if anyone has questions, of course, I think I will be done and will be ready for them.
Thank you so much, Hilmar. Great presentation, by the way. I love the demo. Let me put you back on screen so we can take some questions. We probably have time for 2 questions, so let's just dive into them. So the first question comes from Marcus. As far as I know, currently in beta only, TypeScript is supported. Are there plans to support Python or Rust in the future?
So in general, any sort of runtime works very well. Any sort of language will work in the future. We actually started with a WebAssembly at the very beginning, but that turn out to be a bit more complex, and so people like the TypeScript better. But we will see. I think it will be possible to also support more programming languages, but we will probably have this now for the next 6 months or so, and then might add new ones. But definitely possible, technically speaking.
Great. I'm curious, by the way, what was your experience with WebAssembly when you dove into that initially?
Yeah, so what the problem was with WebAssembly was mostly actually like the whole sort of dependencies that you have for TypeScript, which is great. What is great right now in this Dino environment is you can actually import any sort of NPM packages that you sort of wrote yourself, or the Uniswap NPM package, or any other NPM package you want. So you can basically piggyback on so much that developers before you have built, which is very difficult for WebAssembly because they have to only certain packages will work that are like WebAssembly compatible and stuff. So yeah, that made it much easier to use TypeScript.
Makes sense. And then the last question is, IPFS as a storage layer. Do you have any plans to support other storage layers, for example, such as Arweave? And what does the latency look like in calling out to these storage layers?
So that's a very good question. IPFS sometimes actually has latency issues. That's why Gelato nodes actually cache these Web3 functions that are stored in IPFS locally on their client, and so they to avoid basically having that sort of latency. And then if you update them, they sort of update them as well. But we are actually very open to supporting any sort of decentralized storage layer, and are also already looking into Arweave. So I guess we will sort of play around with it and see if it makes sense to adopt as well. But it's a good question.
That's awesome. I assume it's a pluggable architecture.
Exactly. Yeah. You can even plug it into your own DB if you like.
That's great. Awesome, Hilmar. Thank you very much for being here today. We're just about out of time, but it was a great presentation. Really, really awesome, by the way. And I think we all learned a lot. If you want to check out Gelato, check out their website, gelato.network. If you're a developer, feel free to play with it. There's some fascinating tools they provide there, and it can really accelerate your Web3 development. So Hilmar, thanks for being here. It was great having you.
Thanks, Ed. Take care, everyone.
Thanks, Hilmar. Take care. Guys, we're going to be right back with the final session of today, which is a zero knowledge proof and privacy panel with 4 great panelists, and that'll be our last session. So it's going to be a lot of fun. I know a lot of you are curious about zero knowledge, so stick around and we'll have